Hello, my name is Recep Ozdag. I'm the Vice President of Product Management for NVS. That's Network Visibility Solutions within Ixia. Ixia, of course, is well known as a test company, but we do significant business in terms of visibility. We're the number two visibility company. And visibility monitoring, I'll use these words interchangeably. It's really the same thing. A brief background. Even though Ixia has been around for 20 years, we entered the visibility market with the acquisition of two companies in 2012 and 13. Anui, which was well known for delivering high-performance network packet brokers. We'll spend some time there. And NetOptics, which was the number one tap and bypass company. So we combined these two companies, and in 2016, we launched our first homegrown platform, VisionOne. It basically took the best of breed technologies from both these companies. We added a bit of a secret sauce that comes from test, and we delivered an all-in-one platform. And of course, ever since, we've been delivering network packet brokers since then. But VisionOne is our flagship product. In 2016, we announced our solution for AWS, Visibility as a Service, CloudLens. A couple of months ago at Black Hat, we announced our Active SSL solution, also known as man-in-the-middle SSL proxy. Scott is going to go into details there. And this week, we expanded our coverage of cloud service providers and announced that we now are multi-cloud. So Amazon, Azure, CenturyLink, IBM, and so on. And I'm sure that there's a lot of cloud vendors that I didn't include, but Sushil is going to go into the details. So we have a multi-cloud solution that was just announced this week. Monitoring, really the number one driver for monitoring is security. Simple as that. And the elimination of blind spots. Because if you can't see something, you can't really secure it. And that's really the basics of it. I would say 50 to 60% of the drive for visibility or monitoring comes from security. There's also application performance monitoring, network performance troubleshooting, etc. But the number one driver is security, and for good reason. You know what happened a couple of weeks ago with Equifax. There's not a day that goes by where a security incident doesn't happen. And as with we have more devices, the attack surface is increasing. So we have to eliminate blind spots so that we can send all that data to our tools for inspection. And this is really where visibility comes into play. Now, there are a ton of security tools. How do you connect all these tools to your network? Here's a very simple network, and I've just picked a bunch of vendors in the security space and application performance analytics space. How do you connect all these tools to your network? What if you have a 100 gig pipe and your tools only support 10 gig? How do you connect them? What if you have SSL traffic and not all your tools can decrypt SSL? What do? Do you just throw them out and buy new tools? What if some tools only need the packet header? Do you still send them the whole frame, all the packets? The challenge is that there's a ton of data transitioning in this network, and connecting all these devices is cost prohibitive. It's just financially not possible. So what we want to do is, in the spirit of eliminating blind spots, is have a platform that can reach all the data, but then selectively, in an intelligent way, send the right information to the right tools. And that's what we do with our visibility architecture. It's really a number of products coming together in a very structured way so that you can connect these tools to this network. And I'm going to go into the details soon. To access data in the network, there are a couple of ways to do it. A lot of users will just go with span ports. What is a span port? Span port is really just a mirror port on a switch. The problem with span ports is that it drops packets left and right. It works great when you have very low bandwidth requirements. Now, as the bandwidth requirements go up, remember you're copying, so you're oversubscribing into fewer ports, and will start dropping packets. So the moment that you need to see the data, it will start dropping packets. Therefore, the recommended way is to use a tap. A tap, just as an example, a fiber tap, is really a very simple mirror that will reflect light and copy it. So I can insert taps into my network as a bump in the wire, and it will create an identical copy of the data. So it's used for out-of-band monitoring. It will not send data inside the network, it will just copy it outside. Now, of course, we have taps for copper, fiber, VMware, OpenStack, and we're going to talk about cloud too. Now, if you don't want to do out-of-band monitoring, meaning that you don't...
How does a tap relate to VMware or OpenStack?
Virtual tap. So what's happening inside the server where you have applications running, multiple applications running on one server, and they don't go outside of the server to the switch, the only way to access that inter-VM communication is to have a virtual tap that copies the data.
Yeah. Isn't that a virtual span port?
It's a virtual, it can be a virtual switch, that's one. Right? So we essentially leverage the virtual switch to essentially do filtering. Rather than sending all the data, you selectively send the data that you need.
Okay.
Yeah. And of course, you can do other things. I mean, you can if you want to do SSL decryption there, if you want to just send the packet information and not necessarily the whole frame. So everything that we just talked about, you can do it by controlling the vSwitch with some added functionality. So Sushil or Chris, did you want to add anything?
Did that? I can just turn it on. Right. So did that answer the question for the...
Yeah, there's just a disconnect between span ports are bad because they drop data. And we have a virtual span port, but we call it a virtual tap, and taps are better because they don't drop data.
So yeah, a couple of things. Hardware, software is a little different, right? I mean, if you're doing a span port on a physical switch, among other things, it's really easy to oversubscribe the physical port, which in the software world is a lot less of an issue, right? I mean, the single port bandwidth isn't as big a deal on a virtual switch, right? So you don't have the oversubscription problems, and another problem with actual span ports is depending on how they're set up, you can easily get things like a lot of duplicate packets. And
I don't have a technology problem. I have a
it's definitely, well, I guess for consistency, it's really just I guess the way we think about it, and the implementations honestly have changed over time. The VM implementation is a little different from the OpenStack implementation.
Well, Open vSwitch has.
Yeah. So
VMware doesn't give you the hooks you need.
So just calling it tap, I mean, because from the user perspective, it's effectively a tap because the way you're driving it is you're talking about links between two VMs, right? The way that we present the interface to you is I got these two VMs and they're talking, and I want to tap that link.
Okay, so I'm not mirroring the I'm not mirroring the virtual port for a VM to the vSwitch, but I'm mirroring the
interface that we present to you is more like I've got these two servers talking and I want to tap the connection between them, which is more analogous to
so it's a stream.
Physical tap.
It's a stream, not a port.
Independent of what the implementation on that vSwitch may look like. Okay.
Great. Well, thanks for buying. Now the bypass switch. I just mentioned that with taps, we do out-of-band monitoring. So you send the data, and you can do your sideband analysis, send it to your tools and all that stuff. But if you want to prevent intrusions rather than just watching what's happening, then you want to bring all your tools inline. And this is where a bypass switch comes into play. With a bypass switch, I can bring all those tools inline. It is transparent. So any data that is entering your network will go through a bypass switch, will go through your tools, come back to the bypass switch, and then go back to this destination. So if any of your tools fail, a bypass switch will detect it, and then you have options. You can say, I want to find an alternative path, or maybe I don't want any traffic to enter my network if it's not inspected. Right? So that's where the bypass switch comes into play. So the goal is to tap everything and everywhere because that's the only way to access data. Now, once we have tapped everything and generated all that data, we can't really just send them to our tools because now there's just too much data. In fact, there might be duplicate data. And again, it's still cost prohibitive. So we use these devices called network packet brokers to aggregate and then groom it to filter it so that we reduce the amount of traffic, but intelligently, and send it to those tools. A network packet broker might look like a switch, but it's not a switch. A switch is a device that you put into a network, and then it communicates with its neighbors and forwards traffic based on certain rules. A packet broker might have other intelligence in it. Typically, ours have FPGAs and extra additional compute power, so that you can aggregate the data and filter it and send packets anywhere you want, violating the regular switching rules. So I'll go into details here. But I want to show you a picture of out-of-band. Here, I have taps, physical taps between my links. I might also have virtual taps running on VMware or OpenStack. I aggregate all that data, send it to my packet brokers. Again, there might be multiple packet brokers there. Now, I might say, I only want to look at data coming on a certain port and send it to my tools. I only maybe want to send data on a particular IP address or a MAC address. So I can filter it. I might have multiple tools. Maybe I have a 100 gig link, but I only have tools that can support 10 gigs. So maybe I stack 10 of them up and do load balancing. I can do SSL decryption, or maybe I only send metadata, a summary of the data in the form of NetFlow. Right? Now, this was out of band, right? We're copying the data, nothing is going back into the network. I also mentioned that we have the concept of bypass switches. Here we have a bypass switch, and it's inline. So I can bring all those packet brokers and all these tools inline. Again, the combination of the packet brokers and the bypass switches can detect if any of these tools fail. And if so, it can route around it, or maybe you want to prevent the traffic altogether because you don't want any data that is unexpected to enter or exit the network. Now, we use disaggregated bypass switches, meaning that they're not integrated into our network packet brokers, because you want that bypass switch, which is inline, to have a low probability of failure. By disaggregating it, we can design a very highly reliable device. The simpler it is, we increase the mean time between failure. A lot of our competitors will kind of integrate it to reduce costs, but that is essentially an inferior design, and that's why customers keep coming back to us as soon as they have issues. Again, out of band, where we copy the data and send it to a fabric of packet brokers, and inline, when we use bypass switches and bring all of that inline. Now, I had mentioned that we tap everything. Well, it's possible that you're generating multiple copies of the data. So you don't want to send 10 copies of the identical data to your tools. So maybe you want to do deduplication. Why send 10 copies? Just send one copy. Reduce the bandwidth requirements on your tools. Maybe you want to do SSL decryption. Some tools only want to look at the packet header. Again, why send the whole packet? You're not effectively utilizing your tools. By essentially doing packet level processing, we can reduce the amount of traffic going through the tools, increase the effectiveness of the tools, but still send the right information. And finally, what we can do is, because all the data in our network is going through our packet brokers, we can automatically identify applications. So I can say in my tool, I see somebody streaming Netflix in Brazil using an iPhone 7 on this particular browser. With a simple drag and drop, I can take that user's flow and decide to send it to my tools. And I'm going to show you a screenshot of our graphical user interface. A lot of tools cannot do that. You will have to write regular expression type matching or bit matching to figure out what application this is. But that's challenging because application signatures change all the time. And you can essentially deliver all of this through a single pane of glass. So if I have 10 bypass switches, hundreds of network packet brokers, I can manage them through a single user interface as if it's logically just one entity. And again, I'm going to show you a graphical user interface, which is here. Here is our VisionOne platform, all in one. This is in an out-of-band environment. All the data that's coming from taps is on the left on those ports. The data going to the right is going to the tools, and I can just drag and drop and apply any filter that I want. For example, here, I'm aggregating 2 ports, sending out on here. Clearly, if these are 2 10 gig ports, I cannot really send it on a 10 gig port without dropping packets. So I can apply certain filters. I can apply deduplication. I can apply SSL decryption, and so on. One of our differentiators is really this awesome user interface. Here's an inline. I can see the whole topology. I can see my bypass switches, my packet broker ports, as well as my third-party tools. In this particular case, it's a Cisco Firepower. Right. Another differentiator is that we can provide application-level intelligence. You can see all the applications that are running in your network, IP addresses, geography, etc., all of this. I was talking to a bank recently, and they said that they had sanctioned certain devices and certain applications to be able to run in their network. And they love this tool because now they can see anything that is not allowed still running in their network. So essentially, it's also used as a threat intelligence. Maybe they're not really expecting somebody from China to be accessing their networks. They can easily see that here. Right? So it's application intelligence as well as threat intelligence, because all your data in your network is going through your packet brokers. As you can see, there's hundreds or maybe thousands of applications we can automatically detect. This is a subscription service, meaning that every 2 weeks, there's a new package downloaded to your NPBs. In fact, I think when Pokemon Go came out, we had it here in 2 weeks. So you can actually see, hey, is somebody playing Pokemon Go on my network? Right. So you don't have to try to figure out what is the signature of that application, enter it manually, and keep updating it by yourself. So to sum it up, we use taps for out-of-band, we use bypass switches for inline, and we have a whole slew of leading packet brokers. Now, I mentioned a couple of differentiators. I said one is our graphical user interface, second is our application level intelligence, and third one is that we use dedicated FPGAs in our packet brokers. An FPGA is the next best thing since an ASIC. The reason why we use FPGAs is that, someone chuckled there, but maybe you disagree, but we can definitely talk about that.
No, I just thought it was a good line.
All right. Okay. Thank you, Howard. Oh, I'm gonna tweet that.
I already am.
Well, thank you. So, if you think about it, all that data is coming through our packet broker. So there's a lot of bandwidth. There's a lot of data transmitting, and you might want to apply SSL decryption. You tick, it starts doing SSL decryption. Maybe you want to do packet trimming, tick, and so on and so forth. So the more packet processing that you do, the more power you need. And while you're doing this, you don't want to drop packets. A lot of our competitors will use a regular CPU. The challenge with a regular CPU is that, as you know from your laptops, the more applications that you start running, just open a couple of Chrome tabs, PowerPoint and Excel tabs, you'll see that it will slow down. Same thing with the CPU. The more you start enabling these packet processing technologies, they start to drop packets. In fact, a lot of our competitors will provide you a table and they'll say, well, if you're going to do SSL decryption, don't do NetFlow at the same time, because we can't do it. If you're going to do NetFlow, don't do packet trimming at the same time. With us, you can tick every single one, and it doesn't drop packets. As I mentioned, that's our single pane of glass software. It's basically based on Open Daylight. So it's an SDN controller to manage everything. One thing that I did not cover is CloudLens, our solution for private data centers, private cloud, as well as public cloud. And we have 2 sessions that will be covered by Sushil and Chris. So we're going to go into details there. And no presentation can be complete without the competitive comparison. We do have competition. At least they like to think so. You have your typical switch vendors, such as Cisco, Arista, and Brocade, or what's left over after the splitting of Brocade. These are your switch vendors, and they're slowly adding monitoring or visibility features. Now, they do very simple aggregation and very simple filtering. That's not the main business they're in, but they're adding these features. So if you have a small network with very low bandwidth utilization, they can probably get the job done. Next, you have companies that offer advanced filtering, advanced capabilities. NetScout is one of them. Big Switch, after pivoting for the 100th time, now they're also trying to enter into this business. One company that's going above that does SSL decryption, deduplication type packet processing is Gigamon. Again, just to iterate, we go all the way up to the application level. So that's one, application level intelligence. Second, because we use dedicated hardware FPGAs, we never drop packets. So regardless of where you're operating, you always get full performance without dropping packets. And of course, the third one is our awesome graphical user interface. The reason why the graphical user interface is so important is, imagine you set your system up and you don't touch it for 4 months. And then one day at 3 a.m. in the morning, you get a call, something bad happened, can you come and debug it? If you haven't touched it in 4 months, you don't want to, in the middle of the night, go over a CLI, try to figure out what commands you executed 4 months ago. You want to be able to go to the dashboard and see, aha, I see what I did. Immediately identify what you programmed so that you can focus on debugging it rather than trying to figure out how to use the tool. So thank you very much. I hope that gave you a bit of a background on the fundamentals of visibility and monitoring. Now I'm going to hand it off to Scott to cover active SSL, and then after that, Sushil and Chris will cover CloudLens. So thank you very much.